This video we're going to look at a circle geometry question where I'm given the equation of a circle up here and I'm going to need to manipulate it in order to find out the coordinates and radius of the circle into this form by completing the square for part A. So to complete the square I need to look at the coefficients of x and y as well and use those to complete these brackets. So for the first bracket containing x, I need to think what this value of a is going to be. Well, if I need to get the 2x when I expand it, I'm going to need half of that 1. So that when I expand it, I'll get the x squared, I'll get a 1x, and I'll get another 1x to get the 2x. I'll also get, from the final multiplication, 1 squared, which is 1. So I need to subtract that 1 again to keep it the same. I'll then do the same for the y's. So to get this from y minus b all squared, y there, I need to think, right, I need minus 12y's altogether, so if I put minus 6 in that bracket, so that'll get me y squared when I expand, minus 6y, and another minus 6y to get the minus 12y. I'll also get a plus 36, so again I need to subtract 36. To keep this expression equivalent to this one, I need to make sure everything's there, so I've got to include the plus 12 equals 0 as well. Don't forget about the plus 12. All I've got to do then is get it looking like that. So I've already got the x plus 1 squared in brackets for this. Note that it's okay for a to be negative 1, in which case that negative becomes a positive. I've got y minus 6 all squared for this bit, and then I just need to get the r squared from the remaining constants. So I've got minus 1 minus 36, that's minus 37, plus 12 gets me minus 25 equals 0, and then finally I just need to move that to minus 25 over to the other side to get the r squared. So that's going to be x plus 1 all squared plus y minus 6 squared. Add the 25 onto both sides, gets me equals 25, and that's 3 marks again in that form. Part B asks me to write down the coordinates and the centre of the circle. Now it's in this form where I've got a, b and r. The coordinates, the centre of the circle, which is C, it's given up here, is just a, b. Be careful because it's minus a, positive one's going to be 6. Ask me to find the radius of the circle. Well, this is r squared, where r is 25, and r itself. Note that normally I would say if r squared plus or minus 5, but clearly that doesn't make any sense. Finally, look at part C. So for this. So show that the circle does not intersect the x-axis. Now the key word here is intersect. As soon as you see that in a coordinate geometry question, you should be thinking equations. Well, I've already got the equation up here, which I worked out was x plus 1 all squared plus y minus 6 all squared 85. I'm looking for intersecting the x-axis. Now the equation for the x-axis is y equals 0. So I've just got to solve these two simultaneous equations, and the simplest way is to substitute this one into that one. So it's not going to affect this bracket because that's an x value. This one I'm going to substitute in there, y equals 0. So minus 6, well that's just minus 6 all squared equals 25. So x plus 1 all squared minus 6 squared is going to be 36, and plus 36 equals 25. I then start balancing that out a little bit. I'm going to get rid of the plus 36, botting 36. 25 minus 36 is negative 9. Now at this point you don't need to go any further with the algebra, because you can see I've got an expression in the brackets, x plus 1, and it's squared, and my result is a negative. Now it's not possible to square a real number and get a negative answer. So at this point you can stop and write not possible. So does not intersect, which is the conclusion that the question was asking for in the first place. Okay, right then. So lastly, we're going to look at this one, part D. Yeah. So part D says the line with the equation x plus y equals 4 intersects the circle at points P and Q. Again, you've got this keyword intersect. Okay, so that's going to tell me I'm going to use simultaneous equations again, and it's given me an equation, this time x plus y equals 4. So I'm just going to use that along with the equation I'd already figured. So the equation of my circle was 1 all squared plus y minus 6 all squared equals 25, and I've been given the equation x plus y equals 4. Now at the moment I can't substitute that, I haven't got it explicitly stated what x or y are, so I get either x equals or y equals. Now either one will, if we look at D part 1, it's asking me to end up with an equation with x is in it, so it makes more sense to substitute out the y, so to say y equals 4 minus x, just by subtracting x from both sides of that second equation there, and then I can substitute this into here and eliminate any y's, which is what I want to do in order to form this one. So we can now substitute this one into here, and that's going to get me x plus 1 all squared, that's not affected, and then replace that y with this one, substitute it in, which is 4 minus x, still got the minus 6, all squared equals 25. Equation with just x's in, I just need to show it's equivalent to this. So I'll need to expand the. This first one's pretty straightforward, it's going to be x squared plus 2x plus 1. This one's a little bit trickier. I'm going to just simplify what's in the brackets first. I've got 4 minus x minus 6. Well, that's minus x, and 4 minus x is minus 2 all squared equals 25. That bracket on this next line, I'm going to get minus x times another minus x. It's going to be x squared, as the two negatives multiplied to 4. I'll get a minus x times a minus 2, that's again positive 2x, I'll get that again, so altogether positive 4x, and a minus 2 times a minus 2, so plus equals 25. Squared, x is 4, is subtract sides. 25, gives you 2x squared plus 6 minus 25 is minus 20, which equals again, have a look to get rid of the 2x squared, so just half it, divide by 2 to get x squared plus 3x minus equals 0. You can tell I'm correct because it gave me that equation earlier on. So once I've done that, I can start finding out the solutions to these two. So given that P has coordinates 2, 2, find the coordinates of Q. It might not be immediately obvious what to do with this section of the question, but I've been given a quadratic equation, and that is usually an indication that you're going to be solving it. So if you're not sure where to go, after you see quadratic, solve the quadratic. So I've got x squared plus 3x minus 10 equals 0. Solving that, factorising, pop it in two brackets, put x at the start, and look for two numbers that multiply to make negative 10, add to make 3. That's going to be plus 5 minus 2 equals 0, so x equals negative 5 or x equals 2. Now you can maybe see the link in here. If the x coordinate is 2, that x coordinate is 2. So this solution's already been given for me, so it's this one I need to find the coordinates of Q. If x is minus 5, I want to use my earlier equations to work out what the coordinate y is going to be. Well, the easier one to use is this one, rather than finding it from the circle. You can find it from the circle's equation, but much trickier, so much easier to use x plus y equals 4 and just substitute your value of x in there. So minus 5 plus y equals 4, add 5 onto both sides, gets you y equals 9. It does want the coordinates of Q, write them as a coordinate, therefore Q is at, my x coordinate was minus 5, and my y coordinate I just found was 9. That's the coordinates of Q. Finally, part 3 says, hence find the coordinates of the midpoint of PQ. So this is just a straight line geometry question. All you've got to do, well, you're already given P, it was 2, 2. We're given Q, at minus 5, 9. I've just got to find the midpoint of those two. Well, the midpoint you can find just by adding together the two x coordinates and then halving it. Plus minus 5 gets you minus 3. Divide that by 2 gets you minus 3 over 2. 2 plus 9 is 11. Divide that by 2 gets you 5.5. And there's your midpoint for the final two relatively straightforward marks.